Hello guys, good morning to all. My name is Mohammed Sabir and today I am here with you. And in this session, what we will discuss in today's sessions, we start with a maximum shear stress theory. The maximum shear stress, the maximum shear stress theory. This is also known as a Tresca theory. How you understand this theory? The in earlier video, I understand that like how to solve the machine design problem. Like what is the objective of machine design? Like when we discuss about the machine design problem, what is the basic concept behind it? Okay, now we take a another topic that is this topic comes under the machine design and comes under the theories of failure. Like we have a 5 theories of failure. uh, Among this is one that is a maximum shear stress theory. I think you heard about that. uh, this theory is valid for is what this theory is valid for this theory is valid for ductile material. Like when we design ductile materials, like we are going to make a shaft from a ductile materials like mild steel. How to, like which theory we have to consider to design a shaft? Like we are going to focus on that. We are going to focus on that. We have to design this shaft. How to design this shaft? Okay, this theory is valid for ductile material. Basically, the basic principle behind the theories of failure is what? The basic principle behind the theories of failure is what? Basically, we are going to find the equivalent working stress. Like, what is the FOS? The factor of safety is what? The factor of safety is what? FOS is what? We have a sigma SYT. You also get the SYT and SUT upon sigma equivalent to corresponding theories. You know ki like what is how to find this factor. This factor basically comes through the when we apply the theories of failure to this particular loading system. You know about that. What is the factor of safety? You understand the factor of safety by using one example, that is what factor of safety is basically is what, like we have this shaft. We can apply a 100 Newton load to the shaft, but for the safety purpose, the one council suggests that you can apply a 50 Newton load. Here, what is the factor of safety? Here, what factor of safety is 2. Basically, we design a shaft according to 50 Newton. This shaft can sustain 100 Newton, but for safety purpose, in current situations, we only apply the 50 Newton. What is the factor of safety? What is the factor of safety at this condition? Is 2, because 100 upon 250 is 2. But now I think you understand the concept of factor of safety. Now we come to the what is the maximum shear stress theory. The basic principle behind is like first, what is the key point? What is the key concept behind the theories of failure is what? The theories of failure in a theories of failure, what we do? Basically, we convert the multi-axial loading. We convert the multi-axial loading into the uniaxial case. In a uniaxial case. Okay. I think you understand that what we are discussing. You just say about that. Like we have this matrix. you know, this is a loading matrix. This is a loading matrix, sigma x, tau xy, tau xz. Similarly, you can write this whole matrix. Okay, how to find principal stresses by using this matrix? You can find by using an eigenvalue concept. A minus lambda I is equal to 0. By using that, you can find lambda 1, lambda 2, lambda 3. By using that, we can find the principal stresses is a lambda 1, is a lambda 2, is a lambda 3. Okay, but now we we are going to find that this is a principal stress for this particular multi-axial loading, because we have a stresses, we have a, like, this is a basically an element. Basically we take a element. This matrix is for what? For critical point where stress is maximum. This is sigma x, this is sigma y, this is sigma z, and correspondingly, what is a shear? In a shear, this is xy. This represent a plane, and this represent directions. Okay, and you know this is a sigma 1, sigma 2, sigma 3. Okay, now how to find the principal shear stress? Shear stress. How to find the shear stress? Basically, we have a three shear stresses. Okay, this theory tells about the maximum of sigma 1 sigma by 2, sigma 2 minus sigma 3 by 2, sigma 3 minus sigma 1 by 2. This is a maximum. This represents a shear stress. Sigma difference of a corresponding principal stress by half. This, it basically indicates the shear stresses. The maximum of that shear stress, the maximum of the shear stress must be less than to the strength of that particular maximum in case of this for the multi-axial loading, and this for the maximum of here is what, when we perform a uniaxial test, corresponding uniaxial test in a UTM, like sigma 1 is what, is a SUT, sigma 2 0 and sigma 3 0. Here is maximum of SUT minus 0 by 2, zero minus 0 by 2, 0 by 2. Here comes the maximum of that particular is what? SUT by 2. SUT by 2. Maximum that SUT by 2. And when we equate this, the factor of safety comes. This is FOS. Okay. Now, what actually you understand by this? This for the triaxial loading. Okay. This for the triaxial loading. Sigma 1 by sigma 2 and sigma 2 by sigma 2 and sigma 3 minus sigma 1. Basically, and this for this. Now, how you plot the curve for that? How you plot that curve? This for this is a region. at this line the factor of safety will be 0, will be 1. If the stress, if the complementary stresses are lies within these regions, we can say the stress is, the region is, we can say system is not going to fail, system is safe. Okay, now we understand how we find these lines. We understand how we find these lines. How we find these lines. Okay. How we find these lines are basically a sigma 1, sigma 3. You can say like this is what here sigma 1, sigma 2 and sigma 3. Sigma 2 0 for plane stress conditions. We only have sigma 1 and sigma 3 if sigma 1 is positive and sigma 3 is positive, both are positive. If both are positive, what is the maximum of sigma minus 1 0 by 2 0 minus sigma 3 by 2 okay, a maximum of what? If the sigma, you can say the maximum of sigma 1 minus 2 upon sigma 3 by 2, you know the maxima are maximum lies is going to basically comes through these 2 points. Like how you can understand that, basically sigma 1 sigma 3, you understand that by using that, basically this sigma 1, like you can understand that it depends on that what is the value of sigma 1 sigma 3. If sigma 1 is greater than sigma 3, and it is possible that sigma 3 is greater than sigma 1. Okay, like we comes to that sigma 1 to by SUT by 2, we get a 2 line sigma 2 by 2 for 2 conditions. For these conditions, this lines comes. For these conditions, this lines comes. Okay, and you know when alternative, one is positive, another is negative, so you can understand that among that maxima is this. Easily we can find, we get this line. By using this concept, by using this principle, by using that fundamental mathematical concepts, you can understand how this curve is plotted by using that concept. Okay, thank you, all the best. We will meet in your next sessions with another theories. Okay, thank you, all the best.